All right, so we were distributing. We were multiplying. First two lessons all about kind of multiplying, adding. You knew. Thanks. So we know how to distribute or multiply one thing into many things. We know that we cannot simplify 12x cubed plus 20x squared minus 12x. We just stop there. We know we can multiply two things into two things. And sometimes we will be able to simplify. Same thing here. You're safe. And still not everybody here.
Oh, okay.
If you ask me if I can go to her class for Genius Hour to go to my test.
No.
No?
No.
Okay.
Okay. This is an extension of my class. Yeah, this is, we saved these for a reason, okay? So we are going to be factoring. Factoring is undoing distribution. Our goal from this lesson is to start here and go there. Start here, go here. Start here and somehow get there. Okay? So we're going backwards from what we did last class. We are undoing distribution. When we factor, we make a sum into a product. Could be two things, could be three things, whatever. Okay? We want to turn a sum into a product. There's lots of different types of factoring. Here's examples of what we're doing just in this lesson. In this lesson. We can factor out a greatest common factor. I see 4x and 8. 4 divides into 4, x and 8. I can divide out a 4. Negative 8x squared minus 10x. They both share a 2x. I could pull out a 2, make it negative 2x. And when you're factoring, you're essentially dividing, just like when we are distributing, we are multiplying. If I divide negative 8x squared by negative 2x, I get positive 4x. If I divide negative 10x by negative 2x, I get positive 5. Okay? So, that's some stuff we're doing. Here, sometimes if you got two things being added together, you kind of think and try out them as like two different groupings. And I could say, all right, well, 12a cubed minus 9a squared, 3a squared can be pulled out of both. You get 4a minus 3. 20a minus 15, I could pull out a 5 from both. Give me 4a minus 3. And I still have a sum of two things. But I notice if I consider this to be a term and this to be a term, they both share a 4a minus 3. And I could take that 4a minus 3, pull it out from both of those terms, and I get 3a squared plus 5. My third guy. Well, since I know when I multiply something like this together, essentially my finished product like that was taking these two numbers and adding them together to get a positive 1, and taking these two numbers and multiplying them together to get the negative 6. I can think about going backwards, and I can find two numbers that are being added together to get the 5, and that are being multiplied together to get the 6. I can think of those two numbers. They're 3 and 2. Come on. I don't know why it's something like that. So I can write this as x plus 3 times x plus 2. These are examples of what we're doing today. All right. Here we go.
I'm confused on that.
Confused on the last one? We're going to get there. That was just an example. Okay? It's important to understand that these monomials can be written as products of primes and then just however many x's or whatever you have. This is 12, which is 4 times 3. That's 2 times 2 times 3, xx, y. These are the factors of a term. Well, it's important to understand that if you're adding or subtracting two terms, but they have factors of each other, you can factor out or pull out those factors. Like 4x and 10x squared. We can yeah.
And there's a reason you did 2 times 2 is because 2 times 2 is 4.
Yes.
Oh, yeah,
I mean,
4.
We can just write it as 4 times 3, but 4 can be written as 2 times 2. So just to kind of break it down into prime numbers. Okay, 4x and 10x squared. I can write 4x as 2 times 2 times x, and 10x squared is 5 times 2 times x times x. Now, what do these two terms share? They both have a 2. They both have an x. That means the greatest common factor is 2x. Or, where we're going with this is if I have 4x plus 10x squared, I can pull out 2x from both of those terms. It's essentially like dividing both terms by 2x, which is stuff that we've done. You know, we know how to simplify 4x over 2x. That's just going to be 2. 10x squared over 2x, that's going to be 5x. Does this look familiar to us? Hopefully, yes. Okay? So that's where we're going, but we need to be able to recognize that 2x is the biggest term that we can pull out. Okay? 18 and 27. We could just look at it and figure out that 9 is the biggest number that divides into both, and that we both share 2 b's. If we can't figure that out, we can kind of break this down into a -1, a 9, a 2, b. This can be written as a 9 and a 3, b. I don't want to break it down even more because I can see that 9 is the biggest number that they share. And they also share 2 b's. Which means 9b squared is the greatest common factor of those two terms. Or if I was adding these two terms together, and I asked you factor, turn this sum into a product, I would divide out a 9b squared, leaving me with -2b squared plus 3.
How do you know not to see like 6 times 3 for 18 or something like that? Yeah. You said 50b.
I mean, that's a great question. How do I know that it's not 6, 3? Because if it was 6 times 3 times 2, and this was 9 times 3, and you'd think, oh, it's just the 3 that shares, well, like, I could break this 6 down into a 3 and a 2, and this is a 3 and a 3. And you can see, oh, I share a 3. I share a 3. I don't want you to do this, though, to write down the prime factorization. I'd rather have you just look at these two terms, figure out what is the biggest number that I could pull out of both. Even if we don't find the biggest number, even if I didn't pull out a number at all, I would still be turning something from a product, from a sum, into a product. Let's say I did not pull out any number, I just pulled out a b squared. It'd be negative 18 b squared plus 27. This is still a product. It's still a factored form. It's just we could do a little bit better if I pulled out a number and the b squared.
Why don't you do like negative 2 instead of negative 1 and 2? So like 18 makes sense.
I don't want to confuse us. Okay? Don't worry about it. Okay? All I'm saying is that what is the biggest stuff that they share? They share a 9 and a b squared, which means if I want to turn this from a sum into a product, I can pull out a 9b squared, leaving me with negative 2b squared plus 3. Okay? You try. Figure out what is the biggest term that they share in this sum. Turn this sum or difference into a product by pulling out the biggest thing that is shared between the two terms. Now, when I think about pulling out, I'm undoing distribution. Undoing distribution, where distribution is multiplication, is like dividing. 6x and 9, what do they share? Just a 3. So I'm going to pull out or divide out a 3. Now you can think, what times 3 will give us 6x minus 9? Think about where we started. We started with distribution, and we'd have to multiply this 3 by 2 things. And we should be able to get 2x minus 3. If we can't see it's 2x minus 3, you say, okay, 6x and 9, they share a 3. Divide both of those things by 3, and you should be able to figure out that way. All right? The 4x minus the 16, they both share a 4. So I'm going to factor out or divide out 4. 4x divided by 4 is x. 16 divided by 4 is 4. So I have 4 times x minus 4. Now what's great about factoring is it's very easy to check to see if this factored form is the correct form, the correct product form of my original thing. How can I check to see that this is correct? Just distribute, okay? I could just take this 3, distribute it in like we did for our quiz today. Take this 4, distribute it in, okay? All right, you guys do the next 2. Oops. Now, I'm going to show you something. I'm going to just pull out 2. And I get negative 4x squared minus 5x. Is this a factored form? Sure. But when we factor, we can always think like, can I pull out more? Is there more that can come out of here? Is there more that can come out of here? Do these two terms still share something? What do they share? An x. So maybe let's pull that x out as well. And you can work your way one step at a time to get a fully factored form. If you don't get the entire thing right away, check. See if you can work your way to the fully factored form. Hey, don't like those negatives in there? Pull out a negative 1. Either of these are fine, but these would be considered your fully factored forms. Okay? This one, they share a 3 and an x. Got it? Flip over. We got more. Keep going. Let me show you the first one on the top left. We'll do 5x squared and 5x to the 4th share. Well, let's think. Maybe it's just a 5x. They definitely share a 5. Maybe it's let's start with a 5x. Well, I'd add 5x times x to get 5x squared, and 5x times x cubed to get 5x to the 4th. Do these two terms still share something? What do they share? So pull out another x. Now, thank you. When we pull out an x, x divided by x is 1. A lot of people have things disappear on them. And we could have gone straight to this factored form right away. Okay? But if I pull out a 5x squared from my first term, what has to be there is a 1. So do the second one. They share a 7x squared divided out of both terms. If you want to show this step, you can. You'd have an x squared, the 7's cancel, 2 of these x's cancel with 2 of these x's. Everything cancels, leaving us with a 1. All right, cool. Well, sometimes if we have 3 or more things, we want to pull out something that every term shares. Negative 18y cubed minus 6y squared plus 24. Each of these numbers is divisible by 6. I can pull out a 6 from each of those 3 numbers. Go ahead and do that. Go ahead and do the next one. Now let's say for the next one, I just pulled out a 5. I'd have 2y cubed plus 4y squared minus y. If you're not sure how I got the 2y cubed plus the 4y squared minus the y, I'm undoing distribution. I'm dividing. To distribute, we multiply. To undo, we can divide. Everything divided by 5. However, I see that each of these terms shares a y. I have 3 of them, and 2 of them, and 1 of them. So why don't we pull out 5y, giving us 2y squared plus 4y minus 1. Okay, do the last 2 really quickly. Let's make sure we're all on the same page. Let's say you think 4 is the biggest number you could pull out. You look and you see I can't pull out any other numbers. So you're done. You look to see, can I pull out any more z's? Nope. So you're done. Do the next one. Nope. 32.
Oh, yeah, that's right.
Okay, we get 2y squared, 7y cubed, plus 4y plus 3. Again, if you're not sure how to get the 7y cubed, it's like we're dividing. We've done this before, though. So this is just review. If you only pulled out a y instead of a y squared, you can see I can pull out another y from all those three. And you just keep pulling out things until you can't pull out anything anymore. Okay, sometimes a common factor is like something that has addition or subtraction in it. Notice this is the minus sign. It is separating two terms. This term and this term. These are one term being subtracted from another term. Now, some people's instincts when they see this, just like we did for our quiz, is to distribute, right? Remember, we're going backwards. I'm not distributing. If you're distributing when you're factoring, you're not doing the right thing, okay? We are undoing distribution. Instead, what you can see is that they both share an x minus 3. So an x minus 3 can be pulled out of both of those blue terms, leaving you left over a 7 and a minus 2x. Okay? Do the next three. There's two terms separated by subtraction. The subtraction's right there in the middle. This blue term and this blue term. What do they share? The x minus 3 is shared. I can pull out the x minus 3 from both of those two terms. When I divide it out from here, it essentially cancels there and leaves us with the 7. When I divide it out of here, cancels, leaves us with the 2x. Okay, here, the y plus 4 can be pulled out of both terms, leaving us with 3x minus 2y. Here, the x plus 4 can be pulled out of both terms, leaving me with a 9x, and is that it? Minus 1, good. You can put a 1 there. Here, the t squared plus 4 can be pulled out. I'm left with a negative t plus 1. Because there could be a 1 there. We pull it out of this term. We divide t squared plus 4 by t squared plus 4. That's 1. So just remember, what are we doing? We are dividing out. We are undoing multiplication. One. Is this divided by this? This divided by this with a negative t? Boom, negative t. Okay? Brings us to a very special type of factoring. It's factoring by grouping. If I have 4 terms, sometimes, if something's set up this way, or sometimes it's actually something we will do in a procedure to find a factored form, we can choose to treat this not as as just 4 different terms. Now we can look, do all 4 of these terms share something that I can pull out? 3? No, can't take 3 out of 20. 2? No, not the 15 or the 9. Okay, so we're good. There's nothing I can take out of all. What I will do is treat these as 2 just separate things that I want to factor. This is called grouping. And let's just treat them as 2 different greatest common factor problems. I want to pull out the greatest common factor from these first two terms. Well, I got a 3 and an a squared. I can come out of both of those terms. What's left over, figure it out. From the next two terms, I can pull out a 5. Right? 20 and 15. 5 goes in it. 4a minus 3. And then notice, after factoring both of these separately, I took this guy, factored him to this. Took this guy, factored him to be this. We have a situation just like the one we did where the common factor is binomial, is something with addition or subtraction. Here I have a 4a minus 3. Now notice I have a plus right here, so make sure you have a plus here. The 4a minus 3 can be factored out, leaving you with 3a squared plus 5. Doesn't that work out nicely? Yes. Yes, it can be in any other order. You could have the 3a squared plus 5 and then the 4a minus 3. Multiplication, a times b, same as b times a. Okay, try this one. We got 4 things in a row. Why don't we try to factor 2 groups of 2? There's an imaginary plus 1 right there. Now let's just say I factor out an x. Or, yeah, let's just start with an x. I get 9x plus 18. And I can't pull out anything from the x plus 2, but because of that, I'm going to put a 1 there. Now I see 9x plus 18, x plus 2, not the same thing. Oh, maybe I need to pull out a 3 as well. So I pull out a 3. I get 3x plus 6. Well, 3x plus 6, not the same as x plus 2. Keep going. Oh, I could pull out another 3, making this a 9x plus 2, making this a 1x plus 2. Now, I could pull out the x plus 2's from both of these terms, leaving me with a 9x plus 1. Okay? All right. Jump over, your turn. We'll use this grouping procedure a lot next class when we're factoring different types of polynomials. Make sure you finish off these two. You're missing something. All right, pause on this top left one. I pull out a 2b squared, and I get a 3b minus 4. And I got a negative 9b and a 12. So I'm going to pull out a 3, and I get negative 3b plus 4. Everybody see what we got? Make sure we have a plus in between here. A lot of people forget this plus. You need it. These are not the same. 3b minus 4 and negative 3b plus 4. Am I right? Not the same. So we want to go and pull out the 3b minus 4 or the negative 3b plus 4, but I can't because they're not the same. But I can manipulate something so that they are the same. What should we do? If this was a negative 3, maybe I need to factor out a negative 1, then they are the same. So sometimes you might have to factor out a negative thing. Sometimes you won't. After you factor out a negative so that both of the terms are the same, you can then factor out the 3b plus negative 4, leaving us with 2b squared plus negative 3. Okay, try the same thing for the one on the top right. We are turning sums into products. That is what factoring is all about. Mr. Messer. Sure, we'll do. Mr. Smith, you need to, okay, you're good. So this is r squared minus 6, but this is negative r squared plus 6. I have to pull out a negative 1. It is after doing that that I have r squared minus 6 and r squared minus 6, or r squared plus negative 6. So pull out that negative 1, and now you have r squared minus 6 and 4r minus 1. Okay? Let's look at this guy. Now, you can actually factor this by grouping. Just group them. Go. I'll show you another thing we can do. Do 2x to the 4th plus 6x share anything?
2x squared.
2x squared. Guess what I can do? Pull that out too.
You should just do that from the beginning.
That's exactly right. We could have either factored by grouping from the beginning and then realized, oh, maybe I can factor this out at the end. Or from the start, before I grouped, I could have pulled out 2x squared, and then everything would have changed to be x cubed plus 2x squared plus 3x plus 6. And then I could have taken these and treated them as two groups of 2. Okay, either see that in one of the terms we have a shared factor and pull that out, or you could have factored at the beginning. So let's see if we can get the fully factored form for this guy, either by pulling out the greatest common factor at the beginning or pulling out a common factor from a binomial at the end. I don't like how we do it at the end, but mostly what I would do is pull out the 2x at the beginning. What? Yep. You should get a 2x minus 5, and x squared plus 3. Okay, these are kind of tricky sometimes. I don't like these as much as I like the next ones we're about to do. We'll skip the last one, okay? Save that for practice. Are we ready? Okay. We know how to multiply x plus 2 and x plus 5. It's x squared plus 5x plus 2x plus 10. Well, what I should see is that the two numbers, and if I'm just looking at it, 5 and 2, I'm going to add those two numbers together with an x, because I got a 5x and a 2x. 5x plus 2x, 5 plus 2. And I'm going to multiply the two numbers to get the last term. So, knowing this, I can just look at these and go straight to my fully distributed form, right? I can say this is going to be x squared plus the 4 plus 3x, 7x, plus 4 times 3, that's 12. Right? Right? Okay, do the other two really quickly without doing all of the distribution, all the arrows. Just go straight there. Right? X squared plus 7x plus 10. How do I get the 7? Add the 2 and the 5. How do I get the 10? Multiply the 2 and the 5. Here, x minus 4 times x plus 5. Well, I got the x times the x. I'll have the plus 5x. I'll have the plus negative 4x. Add the two numbers together. I get a plus a 1x. Multiply the two numbers together. I get negative 20. Right? Do the third one if you haven't done so already. You lazy bums. X squared, the negative 2 and the positive 3 added together gives us a 1x. The negative 2 times the positive 3 multiplied together gives us the negative 6, right? Boom, get right there. Okay, well, knowing that, I should be able to go backwards. Because I know that there's some two numbers, hopefully. We'll call this number A, and this is B. I know that A plus B have to give me 9. I know that A times B has to give me 14. And if I can think of those two numbers, and if those two numbers exist, sometimes they won't, but if those two numbers exist, I can quickly and easily just say x plus 2, x plus 7. 2 times 7, 14. 2 plus 7, 9. Now I know that in other math classes, there's some sort of x that comes into play. I don't know what that means. And I know it's like, oh, no, Mr. Master, put your number here, put your other number there. And I'm just like, well, why does this mean add and this mean multiply? Oh, it just does. No, don't do, I mean, you can do that. I'm not going to say don't do that. But understand from the process of distributing why we are looking for two numbers that add to 7 and multiply to 12. And just start here and say, okay, 4x, 3x, 7x, 4 times 3, 12. Okay? That's what we're doing. We are going backwards. This is why it works. Because we know the shortcut, because we know how to distribute, because we know we end up with these two things being added, when I'm going backwards, I'm looking for two numbers that add to get here and two numbers that multiply to get there. They have to be the same two numbers. They end up being number puzzles. You're thinking, and like if you're doing anything, put a plus there, put a multiplication there. You're thinking, I know two terms, both starting with an x and a plus, when multiplied together will give me an x squared, an amount of x's, and a number. Figure out the number puzzle. And that's it. Six and 4. Get it. Do the next one. 3 and 4. Got it. Do the next one. No, we got some negatives here. Same process holds. The two numbers will add to give you a -2. The two numbers will multiply to give us a -8. Figure them out.
We have to add to the middle number.
What?
We have to add to the number.
You tell me.
Yeah. It's x minus 4. X.
And if you are unsure, Mr. MacArthur, what can you do? Think about when you multiply this out. X squared plus 4x plus 6x plus 24, right?
Yep.
You add them to get the middle number. You multiply to get the last one. Okay? This would be a -4 and a +2. This would be a -10 and a +2. Some people love their X's. I won't hate you for loving your X's. It's what you've been taught before. I'm okay with it. Okay. Do these four really quickly. I don't know where the X comes from. That's all I know. I know that if you know how this got to be this, where you're multiplying two things like this, and the two numbers added to get the middle because they were like terms and they multiplied to get the last, that's all I care about. What two numbers add to get -10 but multiply to get +16? Two negative numbers. We can have two negative numbers. Ooh, next gun. This one looks tough. Don't shout out the answer. These are great because they're just number puzzles. This is a number game. All of math is just really a game. It's just a puzzle with rules. Am I the only one who cares about the rules? I don't know. We'll find out. That was a joke. What's that from? From a lot of stuff. 6 and what gives you 40? Nothing. That's exactly right. Let's see. 10 and 4. 10 and 4 combined to give us 3? Nope. 5 and 8. There we go. 5 and 8. Which one's positive? Which one's negative? 8's positive. 5's negative. See? See? What about this one right here? X squared minus 12x plus 36. Negative 6 and negative 6. Very good. Guess what? I can write this as x minus 6 squared. Yep. Flip over. Oh man, do I need two numbers that add to get to? No, hold on a second. This only works when we have an x squared plus a number times x plus another number, okay? This is the product of two binomials, both with x as a leading coefficient, as a leading term, okay? So I'm not using the number game until I get something that looks like this. What should I do? What should I do? I want to factor this. I want this sum to be a product.
You have to take out an x.
They all shared x. Okay. Now, this looks like this. Play the number game. What two numbers add to get 9 and multiply to get negative 36? I'm thinking 9 and 4. No, it doesn't work. 12 and 3. Oh, there we go. One of them's got to be positive, one's got to be negative. Looks like positive 12, negative 3. There we go. We are fully factored. I can pull 2 out. All right. What two numbers add to give me 2 and multiply to give me negative 35? 7 and negative 5. Play the number game. Okay? Sometimes we'll have to factor out a greatest common factor before we move on. Oh, this is tricky.
3x.
3 and 25?
3x. 3x. Just do 3x, and then you'll do your stuff later.
Yeah, but watch. 3x, x squared plus 30x plus 25 thirds. I think Mr. Messner, when he created the notes, probably wanted this to be a 28 or something. Okay, so this is a good example. Sometimes we're not going to be able to factor. It's only when they're a perfect setup will we be able to do this. Okay? All right, hope you enjoyed that lesson as much as I did.